video, I'm going to show you how to run two-way ANCOVA in SPSS. Two-way ANCOVA is to test the impact of the three level of socioeconomic. The three level is going to be measured on read variable, which is the dependent variable. We use covariate right or control the variable right. So we want to eliminate the effect of covariate on the dependent variable read. Also we have another independent variable, schtype, whether have an effect on read or not. So we want to see if there is interaction between the two independent variables, schtype level, then right. Read and write is the continuous variable or scale. So the covariate is going to be right. This is the covariate variable. And the two independent variable, categorical variable, schtype, two level and levels status with a three level, low, middle and high. Before I test ANCOVA, I have to test first ANOVA with three variable, two continuous such as read as a dependent variable and write continue as well, use as a control variable or covariate variable, and two independent variable, categorical variables such as level and school type. In two-way ANCOVA is a little different than one-way ANCOVA. In one-way ANCOVA, I use only independent variable, which is categorical variable, such as levels, status, and one covariate variable with one independent variable, read. And here, before we start, we have to state the assumption for covariate, for ANCOVA. First, all related assumption of ANOVA, like independent observation or random sample. Second, dependent variable approximately normally distributed error. Third, homogeneity of variance, use Levene's statistic. Test linearity, covariate must be correlated with dependent variable, meaning that a linear relation between covariate and the independent variable. Homogeneity of regression slope, meaning that the slope of regression represents the relation between covariate and independent variable are similar. Dependent variable and covariate variable measure a scale or continuous. So here the covariate must be correlated with dependent variable, so we have to test the correlation between the two dependent variables, read and write, and see whether the correlation is statistically significant or not. And last, the independent variable with two or more categories variable. Let me go to SPSS, and here we can see that the data I have to run the general linear model. How? I go to analyze general linear model, univariate, and then here we have the variable, level, independent variable, school type, independent variable, read, dependent variable, without using the covariate in the ANOVA. So I have to go to the model. I leave the full, make sure the full factorial is checked. Then continue. I go to plot, put the level horizontal and school type separated, then add, continue. Then I'll go to post hoc. school type 2 level, so we cannot use 2 key, but with the 3 level and above we can use 2 key, so we have 3 levels. Move it to the other side, select 2 key, continue, and then for the post hoc we can EM means move all these 3 variables to display the mean for, and then compare mean effect, select Bonferroni, and then click continue. Then go to the option, we select descriptive statistic, estimate of effect size, and then observed power, post hoc test, and homogeneity test. Press continue and then press OK. Here we are interested in one table, which is the, as you can see it here, this table here, which is test of between subject. Now I'll check first for the interaction of the variable to see whether there is any interaction. So from this table here, one can see that the independent variable level go to the sig statistically significant, which means that the level, 3 level, are different, are not. So in this case, statistically significant affect the dependent variable read. The school type sig value is 65.5, which is not statistically significant since p-value greater than 5%, and the p-value of the interaction between school type and school type here greater than 5%, meaning that the interaction is not statistically significant since p-value is 73.7%. Here we can see that the sig value change when we add the covariate. The sig value, when we add the covariate variable to the model, to be we go back to the SPSS. This is just to close it, and then go to the SPSS. Now we have to check move to ANCOVA. How to move to ANCOVA? You go back to analysis, general linear model, univariate, and then we leave everything as it is. Just I add covariate to the covariate space. And the second part here, we have to change the model. We go to the model, changes it from full factorial to custom, and move these the 3 variables in the following, as you can see it here. We have 3 variables, and this is two-way and ANCOVA, and level with school type, and level with right, school type with right, and 3 of them, level, school type, and right. So let me move all these variables here to see. This is the variable level by star, school type, then add level by star, right, and then add school type by star, right, and add. Then we move the 3 variables together as interaction, level star y, school type star y, and right, then add. Now we have all the 3 combinations. We move them all together to the other side. Then we have to press continue and OK. Press continue and press OK. What we have here, go to the test between, and this is the outcome. Here we can see that the 3 levels, level intersect school type, intersect with right, the significant value is greater than 5%, which is not significant. So there is no significant between the three variables. And level with school type, not significant. Level with right, not significant. And school type with right, not significant. So here we can see level with school type, the p-value is 90.7% greater than 5%. Level with right is 88.5% greater than 5%. And then we have a school type with right 35.5%, and the interaction between the three variable level school type right is 77.6%, which is all of them greater than 5%. So they are not, we cannot find any significant level in these three variables in the interaction. So we have to assume that we met the assumption of homogeneity of regression slope. The second part, before we proceed to ANCOVA analysis, I have to test the assumption of covariate must be correlated with the dependent variable. How? I'll go to Analyze, Correlate, Bivariate, put the three variable, the dependent variable, read and write, then press OK. Here we can see the correlation between the variable. While we run the correlation, we want to see to have an effect, the covariate should be correlated with the dependent variable as in the assumption. Here we can see that the covariate significantly correlated with the dependent variable since p-value is less than 5%. So when we compare the two output for ANOVA and ANCOVA, we can see ANCOVA tremendously reduce the error rate. To run the ANCOVA, go to Analyze, Compare Linear Model, Univariate, and then we leave everything as it is. We change the model from custom to full fraction, continue, and then when we change it, covariate, and then everything as it is, just press OK. Here you can see output. Okay. It is the output for test of between subject. First we have to look to the descriptive statistic. As you can see it here, low level, private, public, and middle level, private, public, and so on with the total. Here you can see there's the private, the mean of the private 47.88, which is the lowest mean between the middle and the high level. The second table we have to test Levene's, which is the homogeneity of variance. Now we look to the p-value, which is sig. P-value is greater, we are looking for p-value greater than 5% of homogeneity of variance. So p-value here 19.8%, which is greater than 5%, meaning that we met the assumption of homogeneity of variance. Then we move to the table. As you can see it here, the table right significant, as you can see the value here significant, which means that less than 5%, meaning that the covariate is statistically significant, different from zero. We don't have effect of level since p-value is greater than 5%, which is, you can see level greater than 5%, and the school type, the p-value greater than 5%, the interaction is 64.5%, so this means that is not statistically significant, so the interaction level and score is statistically not significant as well, since p-value is greater than 5%. So we look to the estimate, the table here, as you can see it. This is the estimated, and you can see the adjusted mean of dependent variable for level, low level, middle level, and high level. So here we cannot find statistical significance between the three levels. Linearity, and the homogeneity of, so now we'll test for the normality. How? I go to analyze descriptive statistic, explore, and then we have to move the two dependent variable to the dependent list, and then plot. You select STEAM and select histogram normality and continue, then press OK. Here we can see two parts. This is, we can test the normality through the statistical and standard deviation with skewness and kurtosis. And if skewness, kurtosis, statistic divided by the standard error lie between plus 1.96 and minus 1.96, it means that the data or the variable are normally distributed, otherwise they are not normally distributed. The second part, we use the mathematical approach, Kolmogorov and Shapiro. We look to the p-value, sig value. If p-value or sig value greater than 5%, the data is or the variable normally distributed. But in our example, sig value is less than 5%, which is statistically significant for both, and this means that our data is not normally distributed. Also, we can look for normality to the histogram and to check whether normally distributed or not. Then PP plot and PP plot, then the box plot also. Here we can see the line is below in the middle. Below the middle is not in the middle. So in this case, the data seems not normally distributed. And I say it again. We look at the value of Shapiro-Wilk and Kolmogorov, same one. Our guide is if p-value less than 5%, the variable are not normally distributed, as in our example. We are looking for p-value greater than 5%, not less than 5%. If p-value greater than 5%, meaning that the variable are normally distributed. Also, we look at the graphical approach, such as histogram, PP plot, and the box plot, to see the variable are normally distributed or not. And the other assumption we have to test is linearity. How? I'll go to graph, legacy dialog, scatter plot, simple scattered, defined, and here we can see the dependent variable axis, read, write in the x-axis, and level set markers by. And then we press OK. We have this graph here. The test of linearity is covariate must be correlated with dependent variable. This means that a linear relation between covariate and dependent variable using scattered plot diagram. So double click here, go to element, select fit line subgroup, close it, and then close this part here. You can see here the data. This scattered plot indicates that the relation between dependent variable read and the covariant write was a linear. In addition, the scattered plot suggests that the regression slope were similar. All fitted lines. We have three fitted equations. This is the fitted line for the three level: low, middle, and the low is the blue one, and the middle, then the high. All of them goes parallel to each other, which is similar. And if test indicate that there was no an interaction between right and levels. If we are not sure about the three linear, to violate the assumption, we have to test whether statistically significant between the interaction and the other independent variable, right, and levels. Thank you for watching the video. If you like this video, give it a thumb up, and to see more video, subscribe to my channel. Thank you very much.